So what were some like key learnings or lessons you took from Atom in your time there that you've kind of used and integrated
hmm
into Zed?
I think one of the most important ones I think was really think carefully about extensibility. I think at the time in Atom, like um, we had some APIs, but like basically people could reach into the editor and do all kinds of crazy things, which, on the one hand, it was amazing because, it sort of led to this Cambrian explosion of like extensions, right? Like, I think, yeah, the extension store in Atom was like, had a billion things in it on the one hand. On the other hand, now you have a lot of people sort of relying on APIs and it's not version, you don't control it, and like it was really, really painful to just change any API at all. And I remember like when we had to make some like large changes because we had to refactor, whatever, like a major component, we would go through like all the GitHub repos to look for API, users of that API and being like, hey, look, we're deprecating this. Please update to this new thing, this new version. But yeah, that was very, very painful and kind of like, because sometimes the shape of an API morphs also like the performance of that API, right? Like, um, so yeah, that's something that we're like taking very seriously at Zed. Like we're taking a very different path with, first of all, it's versioned, like everything's versioned. So that's one thing. And also just like another thing that extensibility, I think, wasn't really good for, that didn't really like help with in Atom was that, yeah, any package could ruin the editor experience. Like you have stuff running on the main thread and like at any point, a package could, take, you know, even as little as 32 millis, right? That's like 4 frames in a 120 FPS monitor, right? So, yeah, I think being able to control that, I think, is something that we really uh, care about in Zed, and yeah, that was a pretty painful lesson, but I think we learned it.
So y'all had that experience of building Atom, and I mean, I think Atom's success is definitely in its lineage, right? And all the things that's contributed to the space. I mean, VS Code, which is probably the most popular editor today, wouldn't exist without Atom because I think it laid the foundations for that. And then y'all decided to create this new text editor based written in Rust with like a lot of native UI and like very different technical decisions. So, what sort of what led y'all to what Zed is today?
Yeah, I mean, yeah, I think this is also uh, you know, is relevant to one of the another lesson we learned, I think, which was, yeah, I think like one of the biggest problems I think we had with Atom was, yeah, again, performance. Like, what's great about a web browser is that it gives you like this great foundation, right, that you can use to, you have a lot of tools at your disposal. Like you don't have to implement a lot. The downside with that is that like they're buried like deep down and these multiple layers of abstraction that you can't really control. Like I remember man, I forget how long, but yeah, I spent a long time trying to improve startup time in Atom at the time, and like, um, I just couldn't, there were things that I just couldn't remove. Like the browser was just taking a long time to do the first layout, or it took a long time to do its first style recalculation. I remember spending nights like looking at the instrumentation in the dev tools, like the Chromium dev tools, and yeah, like you would just have like 300 millis of this purple blocks, right? And I just couldn't inspect. Like there was no way for me to like inspect it or, uh, you know, change the behavior of it, right? To like make it faster, no matter how hard I tried. And so like I remember we resorted to I don't know if like things have changed since then, so maybe this is outdated knowledge, but at the time, there was this technique called V8 snapshots, like isolate snapshots, where like we would sort of instantiate a portion of Atom up until us, as later as we could, and then like we would snapshot the heap and like store it into a blob, and then like when we reloaded Atom, we would deserialize that into memory, and that was marginally fast. Like we got some speed up, but I don't know. It was like we didn't have enough leverage, I guess. So yeah, with Zed, we started with an empty repo. We were just like, okay, we're gonna do it. Like we're gonna own it top to bottom. And things there are things that we don't do, right? Like there are things that we defer to the operating system. Like for example, if you open Zed, like all the Chrome for the window, right? Like the traffic lights on the Mac, are handled by the operating system. But we wrote our own shaders. We like yeah, it's basically like there's a lot of custom stuff going on, and that comes with downsides, right? Because now nobody knows how this UI framework we wrote, GPUI. Nobody knows how that works, right? Like even when you hire someone, like you need to ramp them up and like sort of explain how that works. I think like it's a really sweet spot where we ended up with GPUI and Zed, but it is true that there's a lot of custom code. And yeah, so that's one side of it. The other side of it is just writing it in a fast language. Rust. I don't know, like we could have written it maybe in C++. I don't know about C. But yeah, at the time, I think Rust really gave us leverage to sort of, it didn't look like a low-level language. It's like, yes, there are problems with the borrow checker. Things have gotten a lot better since we started. But yeah, I think like being able to have like a nice syntax, a really solid type system, and tooling that is batteries included. Like you have a testing framework, like you have a solid dependency resolver. I think that was really good and gave us great leverage.
Yeah, when building a text editor, like response time is top priority, and that 300 milliseconds, like that might not seem like a long time, but in the end, it ends up being huge, right?
Totally, yeah. I mean, I I think like one example of this in Zed is like we use tree sitter under the hood to parse source files and incrementally parse them and like render uh, syntax highlighting and outline view and all kinds of other stuff. And like what we do with tree sitter is like there's this step where like anytime you edit something, we give the parser a chance to do that the incremental parsing step synchronously. So we budget, I forget what it is. I think it's 500 microseconds. Like we say, okay, like we allow you to like parse this, in time for the next frame, right? But if you can't make it, great. Like we'll just interpolate and then like send that snapshot to the background. And then like once you're finally good, like, give it back to us on the main thread, and so we'll display it. So yeah, every little bit counts. So yeah, having a fast language, I mean, 300 milliseconds is like a lot. I mean, I think for startup time, I don't know what our latest benchmark is, but yeah, I think we should be able to start Zed within 500 millis. Like, you should be able to edit, and it's very snappy. Like you click the app, like it appears instantly. And yeah, I mean, another thing is, yeah, like what I just said, like the ability to control what goes on the main thread, what goes on the background thread, right? Like, and not being afraid of race condition. I mean, there are race conditions, but like not being afraid of like, data races as much as in other languages. I think Rust makes that a lot easier. It's not perfect, but I think. I do buy the claim, fearless concurrency. I think it does work.